In the night skies over the Middle East during Operation Epic Fury in 2026, swarms of loud, slow-moving drones drone steadily toward their targets. On the ground, highly advanced multi-million-dollar air defense systems fire frantically, pushed to their absolute limits to swat them out of the sky. This graphic illustrates a financial scale that reveals an unsustainable math problem for modern militaries. A single interceptor missile used to defend these skies cost roughly $4 million. The drone it is destroying costs about $35,000. To understand how this severe economic imbalance originated, we look back to 1979. Following the Iranian Revolution, heavy international embargoes cut Tehran off from the global arms market, entirely preventing the purchase of advanced fighter aircraft or replacement parts. Denied a conventional air force, the Iranian military had to develop an alternative approach. They pursued a concept called asymmetric parity, relying on unconventional, highly expendable weapons to counter adversaries equipped with superior, high-tech fighter jets. By completely isolating the country from traditional aviation markets, international sanctions forced the development of a highly lethal, cost-obsessed doctrine for aerial warfare. In 2011, Iran's cyber warfare unit achieved a massive intelligence coup. They managed to hijack and safely land a highly classified American Lockheed Martin RQ-170 Sentinel drone that was operating in Mariner space. Engineers at Shahed Aviation Industries immediately dismantled the captured aircraft, reverse engineering the Sentinel's composite materials and aerodynamic properties to drastically accelerate their domestic programs. The regime publicly exhibited these prototypes, using the moment as a massive public relations campaign to declare themselves an emerging, self-sufficient drone power. At this point, the military made a critical pivot. Instead of solely building complex, expensive reconnaissance drones that needed to return home, they began designing one-way attack munitions, cheap, single-use drones built strictly to explode on impact. The captured American technology provided the foundational engineering, but the realization that sheer, expendable mass mattered more than aircraft survivability birthed the philosophy behind the modern Shahed. This engineering philosophy culminated in the Shahed-131 and its larger, heavier successor, the Shahed-136, a weapon system widely referred to as the poor man's cruise missile. This exploded view schematic breaks down the Shahed-136's aerodynamic delta wing structure. It carries a devastating 50-kilogram explosive warhead packed into its nose cone. By scaling up the size, engineers increased fuel capacity, granting an operational range of 2,000 kilometers, allowing strikes deep behind enemy lines. To keep production costs low, the drone relies on a Motto MD550 piston engine. This loud, commercially available moped-style motor sacrifices stealth for absolute economic efficiency. Despite strict global embargoes, investigators pulling apart downed drones found that up to 82% of the internal electronics, from processors to voltage converters, are commercial-grade, off-the-shelf components manufactured in the United States and Europe. The engineering brilliance of the Shahed lies in its simplicity. It bypasses military sanctions by weaponizing widely available global commercial supply chains. In 2022, Russia began importing thousands of these drones to bombard Ukrainian cities and power grids. To mask their Iranian origin, Russian forces stripped the branding and renamed them the Garin-1 and Garin-2. Russia quickly transitioned from importing the drones to domestic mass production. They established the Alabuga model, building a massive manufacturing facility in the Tatarstan region that utilizes coercive labor to produce up to 6,000 units a year. Russian engineers rapidly iterated on the imported designs. They added radar-absorbing stealth coatings, swapped in thermobaric warheads, and integrated Starlink terminals to provide real-time guidance over vast distances. This industrial partnership recently produced the Shahed-238. By replacing the standard piston engine with a Czech-made turbojet, this next-generation variant flies significantly faster, drastically reducing the window defenders have to intercept it. Through Russian industrialization, a weapon originally designed for regional harassment evolved into a globally mass-produced, constantly upgrading weapons franchise. By the time Operation Epic Fury began in 2026, the Shahed was no longer confined to Iran or Russia. The blueprint has proliferated across the globe, heavily arming proxy forces like the Houthis in Yemen. Facing massive swarms of these weapons, the United States military is now adopting the same strategy. The Pentagon recently deployed Lucas, a low-cost, one-way attack drone that essentially clones the Shahed-136's operational model. Simultaneously, defense systems are adapting. NATO and Ukraine are actively testing drone walls and deploying autonomous, AI-enabled turrets designed to shoot down cheap drones with standard ammunition, conserving their multi-million-dollar interceptor missiles. A nation's military supremacy is no longer guaranteed simply by owning the most advanced fighter jets or the most sophisticated radar networks. The Shahed ecosystem has proven a brutal mathematical reality. In modern conflict, overwhelming